Okay, this question is called intersection of two arrays. So given two arrays, write a function to compute their intersection. So basically intersection means the common elements between the two arrays. And yeah, so this is the first array, this is the second array. Two are the common, here is 9 and 4 is common between the two sets or two arrays. So the result can be in any order, which is nice, and each element in the result must be unique. And if you go to the related topics, hash table, two pointers, binary search, sort. I will show you the hash table, which is, this is a data structure in Java, but the equivalent to it is dictionary in Python or a normal object in JavaScript. So we can do that. And yeah, we can do that first in JavaScript. Then I will show you a couple of solutions. One of them is for in binary search. Okay, so first thing, I'll create an array called n2, which holds the non-duplicate, or it holds the elements from the second array, after removing the duplicates. There is a fast way to do it, is by converting the array, so nums to a set, and you can convert it this, and we can return it to array like this. So we spread the set into an array. So this is a fast way to convert it to an array. I'm not sure if it's fast from a performance perspective, but I mean, it's really short in the syntax. Anyway, so const map, this is just like the hash table. It will behave like it. So nums1 for each number in the first array. I didn't remove the duplicates from here because I don't think it's necessary, because I will always rewrite them like this. So I'll just store, if we find this number, I'll just put it as a key in this map and the value will be true. Just mark it as we saw it. So we might do this to the same key multiple times, but it's okay. And now const res equal array, and for each element in the second array, which we remove the duplicates, if the number exists as a key in the map, just res.push the number, and at the end return this, and that should be it. Submit. So yeah, it's fast, but let's do. So you can convert this solution into Python. So without the map, we should just use dictionary, and everything else would look almost the same. So I don't need to convert this to Python, but I'll show you something interesting in Python. So in Python, I'll choose Python 3. So there is this function called intersection, which should behave like we want on sets. So we can just return, convert the first array into set, then intersection with a set, another set, which is from the second array, and all of that you need to convert it to a list, since we should return a list, and that's it. This is also a solution. Okay, it's nums2, sorry. I keep doing this mistake. I can't submit it. Okay, so this also works. This is a built-in function. But one of the related topics was binary search, so we can just do that. I'll show you. So just return an empty list for now. Now we can define our binary search function. So it's just normal binary search. So binary search. I think this is the main idea behind the question, the binary search thing and the map thing, the map data structure. And the item is integer, low is integer, and high is integer. Low and high is the same as left, right. So we will pass the list, pass the item, and it should return true or false. So mid equal to integer of high plus low over 2. So this will be a float. I will convert it to integer. So it will be a valid index. So if low is bigger than high, which means we kept calling the function recursively until we didn't find any value. And that means we kept going to the right and nothing happened. So this is one of the stupid conditions. So we'll just return false. And now if we found a list, if we found the element in the index of mid, okay, we just return true. And now if that didn't apply, didn't fire, if mid is bigger than the item, return self and call binary search list item no mid -1, which means we are going to the left. So we'll start from the first index, the low first time, to the mid -1. We're going to the left. If the item you are looking at is less than the item we found, we will just go to the left. So the list we pass should be sorted if you think about it. This is usually the case in binary search. Although we can use it without being sorted. There is some questions where I used it like this, without the array being sorted. So list item. Now we need to go to the right. So we'll start from mid +1 to the high. And yeah, first thing, I will remove the duplicates. So yeah, I'll convert the nums one to a set, then return it to a list, and I need to sort that. So sorted. Okay, and now I will use list comprehension just to build this list. So for each number in the set of nums 2, I will put it in this list if self.binary search. So I'll just copy this. So if this returns true, I will just put it in the list, else I won't put it. So I will pass n1, the sorted list, the element in the starting low, and then n1 -1 as the high, and that should be it. Submit. It's not that fast, but it works. Okay, we'll just, if you want to stop the video, look at this.